So this is me trying to write with an eraser. This is 4.4 part 3, right? And we are still talking about trig functions, right? Trig functions of real numbers or any numbers. I'll call it real numbers because that's pretty much what we're working on now, right? When we're talking about trig functions of real numbers, if you remember, we've got our little chart that we did, right? Where we talked about if I have sine, cosine, or tangent in each quadrant, whether or not it would be positive or negative. Now, if we remember, sine of theta is equal to y over the radius, right? And in this section, y, the radius is always positive. So in this section, y is positive, so sine would be positive. We know that cosine of theta is equal to x over the radius. And in this section, x is also positive. And since tangent of theta is equal to y over x, tangent would be positive as well. And remember, we went over that, and I'm going to redo all of the quadrants just so you could see them as we do these problems. Over here, sine is y, but y is positive, so sine would be positive. Cosine, though, x is negative in this quadrant, right? Anything on this side of the y-axis, x is negative. And so cosine would be negative. Tangent is y over x, which means we've got a positive over a negative, which gives us a negative. And that's the most important thing we need to know is like, what are the signs of this? Otherwise, anytime we find these reference angles, they're going to be the same, whether it be in this 0 to 90 degree, or I should say 0 to pi over 2 area, right? They're all going to be the same, whether I'm at 30, 60, 90 when I find that reference angle. But we need to know what signs they are, right? Here, if I look at sine is y, and y is negative under the x-axis. Cosine is also x, which means, cosine, I don't know why I wrote it in y. Sine is negative, cosine is negative. And tangent, think about tangent is sine over cosine. So a negative over a negative gives us a positive. If we look over here, sine is y, and y again is negative. Cosine is x, and x on this side is positive. And tangent is sine over cosine, which would be negative. And so the most important thing to know that's different than any other 30, 60, 90, or pi over 6, pi over 4, pi over 3, right? Those 30, 60, 90 spots is that the only thing that's going to change depending on your quadrant is what sign it's going to be when we find those reference angles. And the reason for that is if we look at what we're getting when we do these angles, say I have something like this, right? And I have this angle right here that goes to say right here, and this has some point on it, right? That's an x, y value, right? This being our theta, right? This is our initial part of that angle, and then it goes to the terminal part, and we call this theta. And if you remember, when we're looking for a reference angle, it's this distance from here to here that we call our reference angle, that theta prime. And the reason we can use that reference angle to figure it out is if, like, we clearly don't have a right angle in our theta, right? It's way bigger than 90 degrees. From here to here is bigger than 90 degrees. But if I were to drop a line straight down here, I would have a 90-degree angle. And so when I figure out this theta prime, it gives me that same solution for what would be that angle in our original theta. Like, we can use that to find it. Does that make a little sense? Like, we're solving it from the back end of the angle. Does that make sense as to why we can use that? We're still using a 90-degree angle because we're creating one on the opposite end of it. We're using that reference angle, right? Because now that reference angle that we find right here is opposite a 90-degree angle. And that is why it works. When we are evaluating the trig function of any angle, when we're evaluating the trig function of any angle, first we want to determine excuse me, determine the function value of the associated reference angle. Right? That's theta prime right here. Theta with the little line above it means theta prime, right? So the first thing we want to do is we want to find out what that reference angle is. This is our original angle that they're giving us, this theta right here. We want to find the function value of the reference angle. 2, we want to, depending on the quadrant, depending on the quadrant in which it lies, determine the sign. What I mean by sign is odd or even, right? It's positive or negative, not odd or even. So let's look at what that looks like in real terms when we're trying to find these bits. They have this thing with common values, and I meant to clip it so that I can interject it here where we can, as a matter of fact, give me a second. I'm going to try and see if I can bring it up and interject it in so that if I can find it here really quick, I'll put it into our lesson. But I will definitely also um, put it into Power School for you guys so that you have it. What can I do for you?
Is it okay if I went back in here for like probably an hour and a half?
Oh, yeah, I'll be here.
Sure, just need to run some errands real quick.
No worries. No worries.
I'll be back for sure. Okay.
See you later, Hazel. Um, see if I can find the book, the e-book. It'll help us so much to be able to see this and move it along with us. Has anyone attempted the 4 point for the part 2 homework that we had earlier this week? Just like that. There it is. Let me go snip that. Everything gets dark when you snip. So you'll be glad I did this because one, it will help you do your need a little help with the reference angle involving a decimal. We can work on that. I might have some in here. You just have to know where it lies in relation to pi. But once I get finished with that, I'll show you exactly what I mean. Once I get finished with this part, because I don't think I have any like that in my examples for today. But I can get one. It's going to be a very boring spot on the video. But it's a very little helpful, peaceful piece of information to have, right? This is all of our 0, 30, 45, 60, 90 degree, 180, and 270 sine, cosine, and tangent, right? It also has it in radians listed right underneath. So you don't have to go do the math on all of those, right? They're right there. So if we need to evaluate reference angles, which is the whole point of what we're doing, we want to start using these reference angles, how we're going to use them. Right? We learned how to find them the other day. If you remember, we had if something fell in quadrant 1, it just was what it was. But if it fell in quadrant 2, we would go with theta prime equals 180 minus theta, 180 degrees minus theta, or we had theta prime equals pi minus theta, depending on whether or not we were working in radians or degrees. And then you had, if it fell in quadrant 3, we would do theta prime equals theta minus 180 degrees, or theta minus pi. And then lastly, if we had it in quadrant 4, we would go theta prime equals 360 minus theta, or theta prime equals 2 pi minus theta. Do you remember those formulas that we came up with for finding the reference angles? I hope so, because that was a whole lesson. So using these pieces of information, what we have here, and these formulas, we can solve bigger angles using the reference angle. So if I say let's make a big pink mark on the screen. If I say let's evaluate cosine of 4 pi over 3. Now, again, it would also help you to have a unit circle to see where 4 pi over 3 would lie, right? And I can make one really quickly here. Right, we could go, let's see if I can make a good circle. Well, that was a mediocre circle, but it would work. Right, say I've got, can't draw a straight line. I can make a mediocre circle. Say I've got 30, 45. Actually, let's do it like this instead. Say this is my 30 degrees, right? This is going to be pi over 6, right? Because if I'm breaking them in 30-degree increments, do you remember this when we did the unit circle? If I'm doing 30-degree increments, that's like dividing this into 6 from here to here, right? From 0 to pi or 180, depending on how you want to look at it, right? This would be 1/6 of pi. This would be 2/6 of pi, which is pi over 3. This would be 3/6 of pi, which is pi over 2. 4/6 of pi, which is 2 pi over 3. 5/6 of pi, which is just going to stay the same, so it doesn't reduce. 6/6 of pi is just pi. 7/6 of pi. 8/6 of pi is 4 pi over 3. 9/6 of pi is 3 pi over 2. 10/6 of pi is 5 pi over 3. 11/6 of pi. And then over here we would have 2 pi. Do you remember that when we did that, when we created the unit circle? Now you could just bring up a picture of the unit circle. If we did it in 45-degree angles, we would be cutting everything into fourths, right? Should probably use a different color to show that a little bit better. Let's do blue, right? If we were breaking it in, I can't make lines today. So if I was breaking it into 45-degree angles or fourths, right, we would just have lines here and we'd kind of count them out the same way. Now, granted, you could just look up a unit circle. You don't have to remember how to do all of this. But this would be like pi over 4 because it is 1/4 of the way to pi. This would be 2 pi over 4, but when we reduce that, we got pi over 2. This would be 3 pi over 4. 4 pi over 4. 5 pi over 4, 6 pi over 4, but we've already reduced that, 7 pi over 4, and 8 pi over 4 is. Why am I telling you all of this? Because it will really help for you to be able to see it when we're doing this so that you kind of know where it goes. Maybe in PowerSchool, I'll also post a unit circle so you've got that to refer to. And so we need to find the cosine of 4 pi over 3. And we're using the reference angle to do that. And what do we know is that 4 pi over 3 is down here. It's down here in quadrant 3, right? It goes all the way around to here, 4 pi over 3. So we need to find the reference angle for 4 pi over 3, which is going to be here in quadrant 3. So we are going to use this formula right here, right? That theta prime that we want to find is going to be theta, which is 4 pi over 3, minus pi, right? And so we're going to have to find a common denominator, which fairly easy to do because our common denominator is going to be 3. So we're going to have 4 pi over 3 minus 3 pi over 3, and we're going to be left with pi over 3. Does that make some sense to you right there? Did that help a little? Yes, no, maybe? Some input. Thanks, Belly. Anybody else want to throw down a yes or no? Well, at least I got 2 people paying attention. 3, I got 3 people paying attention. That makes me feel good, like I'm not talking to myself. So at pi over 3, what do we know? We know that we're looking for cosine, right? We're looking for cosine of 4 pi over 3. And we know that that is equivalent to the cosine of pi over 3. The only thing that would change is the sign, right? Pi over 3, cosine of pi over 3, if we look at our chart, is 1/2, right? Now we just need to remember, well, what is the sine? What is the cosine, right? Is it positive or negative in this quadrant? Well, cosine and sine are both negative in this quadrant. And so this would be negative 1/2. And I know that was a little shaky, but we'll look at another one, okay? We'll look at another 2, and then I'll let you be. I have like 5 more that I can show you, but I'll stick to, maybe I'll show you 3 because there's another one I want to show you. What if we have the tangent of negative 210 degrees, right? If I'm looking at negative 210 degrees, right, it's like saying that we're starting here like normal, but we are going 210 degrees in this direction, right? And if I get here, I get to 190. If I get here, I get to negative 180. And if I get to about here, I get to negative 210, right? If I keep going, like this would be negative 270. And so we can say that this is negative 210 degrees, right? We need to know what that is in terms of a positive. So we need to figure out this direction, right? We know that it's this direction is negative. We need to figure out what it is in this direction. And the easiest way to do that is to realize that if we add them both together, it makes 360 degrees, right? Because it's a circle. So we can just go 360 minus 210 degrees, and we would get what would we get? We'd get 150 degrees, right? And so we know that the positive version of this is 150 degrees, right? We know that tangent of negative 210 is the same as tangent of 150 degrees. And so we can use that to find our reference angle. So now we know that it is in quadrant 2. And so we can go up to the formula for quadrant 2 and go, well, that is just 180 minus theta. So when we're looking for our theta prime, right, we can go, well, that equals 180 degrees minus theta, which is our 150 degrees. And we would get that that equals 30 degrees. So we could go that tangent of negative 210 degrees is going to be equal to 30 degrees, right? Which is tangent of 30 degrees is radical 3 over 3, and we just have to figure out what the sign is, right? So we know it's going to be radical 3 over 3, and if we look at what tangent is in the second quadrant, we have a positive over negative, so our tangent is going to be negative. So once we find it, we just have to figure out what the sign is, right? All your solutions are in charts for the most part. See, Nick, now I want some apple juice. I had one other problem I was going to do, but I'm going to skip over to the last one that I had because there's something I want you to see before I let you go, because in case you come up with a problem like this in the homework, I'm not sure if you got one. If I have cosecant of 11 pi over 4, think about what that means. 8 pi over 4 is 2 pi. It goes all the way around the circle, right? 11 pi over 4. So if I have an angle, right? Here's my angle. It's where it starts. If I take it all the way around to here, it's 8 pi over 4, right? If I take it up to here, it's 9 pi over 4. If I take it to here, it's 10 pi over 4. And if I take it to here, it is 11 pi over 4. So think about that. Like, it wraps around more than once, but it's still going to end up in the same place. So we can say that cosecant of 11 pi over 4 is the same as 3 pi over 4. If I don't have a unit circle in front of me, I could figure that out, though, because I could just go, 11 pi over 4 minus 2 pi, right? If I wanted to know where that landed, I could go 11 pi over 4 minus 2 pi, right? Where I'd have to find common denominators, which would be 4. 11 pi over 4 minus 8 pi over 4 would give me 3 pi over 4. So we can say that this is equivalent to the cosecant of 3 pi over 4. And that's what we will use to find our reference angle, right? And so once we know what that smaller reference is, I can go, okay, well, we need to find this reference angle. It is in quadrant 2. So we're going to go theta prime equals pi minus, oops, not equal, pi minus 3 pi over 4. Right? We're going to find our common denominator, which will be 4 pi over 4 minus 3 pi over 4, which just gives us pi over 4, which means that so far right now we've got cosecant of pi over 4 is equal to, come on down, cosecant is the opposite of sine, right? Pi over 4, sine would be radical 2 over 2. So cosecant would be 2 over rad 2. So we got to do a little math on that. Multiply it by radical 2 over radical 2. We get these. Sorry, I didn't mean to cancel that. That was a bad move on my part. We get 2 rad 2 over 2, which is just radical 2. Right? So we can say now that this equals radical 2, but we need to know what the sign is, right? Is it positive or is it negative? And in this quadrant, we're dealing with sign, which is y, and so it would stay positive. This would be our solution. So that is my last example for you today. Oh, are we there yet though? Yeah, we're there. We used the reference angle to get there. Okay, I wanted to make sure that I had solved out the whole problem because I found the reference angle. All right. Any questions, or do you need to play with it, or what? I would like to have gotten a little bit more done in terms of sample problems, but feel free. I will not be in tutoring this afternoon because I have to go sign 8 million folders in the NPR. But if you need time, if you need a few minutes, just let me know. I can always find a few minutes here and there to put you guys in. All right. I'm going to stop the recording